Recall in this example, example 4, that we were given that y is equal to the arcsine of x, and then we were going to use that information to find some other trigonometric functions of y, namely cosine of y, which we did in class, and then also tangent of y, which I'm going to show you today. So to start this problem, you need to keep in mind the inverse relationship between arcsine and sine, right? Those functions are inverses of one another. So if y is equal to arcsine of x, that means then that sine of y is equal to x, right? Because we can just invert the inputs and the outputs in the inverse function. So we know that sine of y is equal to x, and that allows us to think of y as an angle in a right triangle. So what I've done here on the right is draw a representative right triangle, including y as one of the angles in the right triangle. Now, since sine of y is equal to x, we can rewrite x as x over 1, and then we can insert those values into our right triangle. Because remember, sine means opposite over the hypotenuse, right? So if sine of y is x over 1, then we can label the opposite side of y in this representative right triangle as x, and then we can label the hypotenuse as 1. And that allows us to solve for the adjacent side of y. So I'm going to call that a in this picture, and then I'm going to use the Pythagorean theorem to solve for a, right? So we know that a squared plus x squared, right? The sums of the squares of the two legs of the right triangle is equal to the hypotenuse squared, so that's 1 squared. And now we're just going to solve that equation for for a. So we come up with a is equal to the square root of 1 minus x squared. So we did this in class last time, right? And then once we knew the three sides of the right triangle, then we were able to, of course, compute trigonometric values of the angle y. So we came up with cosine of y is going to be the adjacent over the hypotenuse. So that's square root of 1 minus x squared over 1. And now we also want to find the tangent of y. Well, of course, tangent of y is going to be opposite over adjacent in a representative right triangle. And now that we've got the sides of our right triangle labeled, then we can compute this tangent, right? So it's going to be opposite, which is x, over the adjacent, which is square root of 1 minus x squared. So there is an expression for tangent of y, x over the square root of 1 minus x squared.